Hi everyone, today I am going to start a new video series about RAG, Retrieval-Augmented Generation. In this series, we will go step by step from the basics to advanced concepts. In this series, I will cover what is RAG, why it is used, and how it helps LLM give more accurate and up-to-date answers. So this is the whole syllabus of this series. What is RAG? Embedding, chunking and pre-processing, vector database, retrieval strategies, multi-query, re-ranking using cross-encoder, local RAG with Ollama, build a Streamlit chat app using RAG. So these are the topics that we are going to cover in this series. In this series, I will be using Ollama for running models locally. In today's video, I will cover the basic definition of RAG. You are already familiar with LLMs, right? It can answer most of your questions. Let's say you want to create a chatbot using a LLM that can give information about your working company. So this chatbot should answer all of the queries that are related to your company. But the LLM cannot answer it properly because it doesn't know about your company's information, right? So we should feed the LLM with your company's information. Similarly, if you want to create a chatbot for particular domain, for example, medical, finance, law, etc. In this case, you should feed the LLM with your custom data. That's where the RAG comes in. So what is RAG? RAG stands for Retrieval-Augmented Generation. It's a technique where an AI model doesn't depend only on what it trained on. Instead, it also retrieves relevant information from your own data like PDFs, Word files, websites, or databases. So when you ask a question, the system first searches for the most relevant documents, extracts the useful parts, and then gives that to the LLM to generate an accurate and context-aware answer. This means the model can give factual, updated, and custom answers based on your data. This is a high-level diagram of the RAG. In the first step, you can see the document's data is converted to vector embedding and saved in the vector database. For example, if you are building a RAG for medical purposes, you need to convert your medical related data to vector embedding. Mostly you have these details in PDF format, so you need to convert using the embedding model and save in the vector database. So when the user asks a question, that question is also converted to embedding using the same embedding model and searched in the vector database for similar text. And the retrieved data will be passed to the LLM with user's query. LLM will process the data and give the relevant result to the user. So that is the high-level architecture of RAG. Now we can check some of the use cases of RAG. First one is PDF or document chatbots. You can ask questions from policies, textbooks, medical reports, contracts, research papers. Enterprise knowledge assistance. You can use RAG in companies for HR policy, QA, IT troubleshooting, employee onboarding, etc. Customer support automation for FAQs, product manuals, troubleshooting docs, etc. Medical and healthcare support. We can retrieve context from medical guidelines, patient records, lab reports, research articles, etc. So these are some of the use cases of RAG. In today's video, we covered what is RAG, its use cases and basic architecture of RAG. I hope you understand the concepts. In the next video, we will be covering vector embeddings, similarity search, distance metrics, etc. So that's all about today's video. If you found this video helpful, please consider to subscribe the channel and like the video. Thank you for watching and see you in the next video. Bye.